this is a little disconcerting for people. Give me that. Yeah, so do make sure the part is clean. This is a little disconcerting for folks because this piece that's in the chuck right now, we're going to leave in here. Okay, come around here and take a look at it. The way this is going to work is our part is going to be up against that. We call it a spud. Okay, it's going to be up against the spud like that. Okay, now there's nothing holding it, right? So we need a way of holding it. So that's what this guy is going to do. Our tailstock has a live center in it. Okay, it's loose. And so setup can be a little bit of a challenge here. So the way we're going to do this is, this handle, pull it straight back, unlocks our tailstock, allows it to come forward. And so we have to do a little jockeying here. And I'm going to take my part with my fresh center drill hole, bring the tailstock nose up against it, and that's what's going to hold it in place. We're going to apply pressure with the tailstock, and this is what's called a friction drive. The friction between this piece back here and the back of our part, with that pressure on it, it's going to drive it around, okay? So, but before I can do that, I need to make sure I've got clearance for everything to work. So I need this tool here to be able to move back and forth across the face of my part, okay? So I need a little bit of clearance to do that. So I leave everything loose initially. And what I'm looking for is with the tool, I've got a stop, a work stop here for the carriage so I don't crash into my chuck. I'm gonna first butt that up against the work stop, bring the tool nose back until it just clears the back of my part, because I don't need to go any further than that. That way when I hit contact the stop, I know it's not gonna get into anything, okay? Conversely, at the other extreme end, I need a little bit of room here to actually start the cut. So as long as I got this much travel, I'm happy, right? So just a little bit more, okay? So 2/10 if you just want to lay a scale up there just for grins and giggles. So if you got about 2/10 clearance on the back side, fine. And on the front side there. And so what I'm looking for now is, if you look right in here, between the cross slide mechanism and the base of the tailstock, I want at least a thumb's width of clearance as you see it now, okay? That means I have enough room to get all the way back away from the part on this side, okay? So if I'm happy with my clearance, then I will lock down my tailstock, back this away a little bit. Again, just a quick sanity check. And now I'm going to leave it loose initially, get this out of the way. I'm going to turn my machine on. Once it's running, then I will start tightening this up. The reason why I do that is these tailstocks are getting a little worn and they have a little bit of a droop. So the tip of this thing isn't exactly on bore center of my lathe. And so by turning it on, I force it to go on center and center my part up, right? So it doesn't persist. So here we go. I'm gonna turn it on. And I'm just going to slowly tighten this up. Double check that. Okay, so it's fairly tight, okay? Don't be shy, okay? Sometimes you can actually feel this thing move back a little bit. If it starts moving back on you a little bit, just give it a little extra here. But we want enough pressure to generate that friction on the backside. If not, the split second the tool contacts my work, this thing will stop, okay? If that happens, just quickly stand on the brake. Because if it sits there and stays stopped for too long, it will literally friction weld this to that because they're the same material. They're both aluminum, they like each other a lot. Okay. Okay, so now I've got that set up. Now I can start the process of actually turning the outside down. So what I'm going to do is bring the tool till it's about center of my part, and just kind of by hand I'll rotate this and get it in fairly close, like that. Not contacting yet. I'll turn the machine on and I'm going to slowly come in with my cross slide till the tip contacts the work. You will hear it, okay? At that point, this guy right here, this is a slip ring, unlike our mills. Just hold the outside and you can slip this whatever direction you need to go to. I'm going to set it to 0 once I contact, because I want to keep up with my depth of cut. If I go too far, because of the nature of the connection here, I can overwhelm that by taking too heavy a cut. So here we go. So here's the contact. Set it to 0. So what you need to know here is there are 2 rings. The inner track on this one is millimeters. The outer track is in inches. This machine, the outer track is in millimeters. The inner track is in inches. Again, slight differences. It shows you very clearly what each division is worth. So on this one, so every 1 division is worth 0.002 inches, 2/1000ths of an inch. What that means for us, 2/1000ths of an inch, it will reduce the diameter 2/1000ths of an inch. Not 2/1000ths per side. Some people get a little confused because this thing is spinning in space. Okay, it will reduce the diameter 2/1000ths, so it's direct reading. If I want to take 10/1000ths off the diameter, I dial in 10/1000ths on my dial. Easy as that. Okay, so now I've got a reference point stopped. I'm going to back away from my part, and I'm going to do this in 40,000ths increments, 40,000ths depth of cut. I use 40,000ths because it just happens to work out with this dial very easily. This is 200 per revolution, just like our mills. Okay, so it's easy to keep up with. So I'm going to dial in 40. So there's 40. I use this machine because it's much easier to read, because that one's backwards. You kind of can't see what's coming up. So you'll see that if whoever uses that machine. So I'm going to dial in 40. Now, I could turn the machine on and then run this across here by hand, right? But I don't want to do that. I have power feed. And so what you need to know here is this lever is the only one you want to manipulate. Leave this one alone. Don't touch it, don't put it down, do whatever. If this is down and we flip this one up at the same time, this is what's called the half nut. This is what we use for threading outside. The half nut sends it direction in this direction, while this one wants to send the carriage in this direction, and the net result is broken gears, right? So if we leave this one alone, all is well in the universe. Okay. So here's how this works. As soon as it gets to the end of the part, to the middle, back it up, 40 more, there's 80 indicated. And you're just going to keep repeating that process, and as you can see, it's starting to knock the corners off this until it gets round. Occasionally stop and look. So we're looking for these flats to just start to go away. It doesn't have to be completely round. If it's mostly around 80, 90%, it's at a point where I can take a measurement of the thing so I can hit my final target. So let's do that real quick. Hand me that little bottle of cutting fluid on the toolbox over there.